Hey everyone, welcome to This Explainer. Today, we're completely demystifying supervised machine learning. We hear the term machine learning thrown around constantly in the news and tech keynotes, right? But what does it actually mean? Well, today we are going to strip away all that confusing jargon and show you exactly how computers learn from data to make highly accurate decisions. And don't worry, zero complicated code is required. Let's get right into it.
Here is our roadmap for today. We'll start with the basics of supervised learning, walk through the actual machine learning pipeline, compare classification and regression, peek at how different algorithms think, and finally, look at how all of this drives better business decisions.
So think about this for a second. How does your computer actually know if an email is spam? We all use spam filters every single day, right? But how does your inbox instantly know that an email offering you $1 million from a mysterious prince is pure junk, while a message from your boss is totally legit? It's not magic, and there certainly isn't a tiny human sitting inside your computer reading your mail to sort it. It is actually supervised learning in action.
All right, let's kick things off with Section 1, the basics of supervised learning.
Okay, so what is it? Basically, supervised learning is training algorithms using labeled data, what data scientists like to call the ground truth, to teach models how to map inputs directly to target outputs. Think of it exactly like a teacher handing a student an answer key. The model learns by continuously making guesses and then comparing those guesses to the known correct answers. Because the data we feed it is already labeled, the computer learns the relationship between the input and the output. That way, when it sees brand new, unlabeled data later on in the real world, it knows exactly what to do. Let's look at a really concrete example of how we structure that labeled data. We are explicitly mapping our input features directly to our target output. So the algorithm looks at input 1, which is the size, and input 2, the location, to determine that target output label, the price. By chewing through literally thousands of these rows, the machine picks up on the underlying mathematical patterns. It starts to learn things like, hey, bigger houses usually cost more, but a downtown spot might jack up the price regardless of the square footage.
Moving right along to Section 2, let's look at the machine learning pipeline.
To get from raw data to a working model, information has to travel through a very strict step-by-step pipeline. The absolute crucial point here is Step 2, splitting the dataset. We usually take about 80% of our data to train the model, and we hide the other 20% to test it later. Why? Well, imagine a teacher gives a student a practice test and then uses those exact same questions for the final exam. You wouldn't really know if the student actually learned the concepts or if they just memorized the answers. The same exact thing applies to machines. We train them on the 80%, then evaluate their accuracy on the 20% they have literally never seen before. That's how we know it's going to work.
All right, Section 3. Once that pipeline is running, we hit a fork in the road: classification versus regression.
These are the two major buckets of supervised learning, and the fundamental difference is actually super straightforward. Regression is purely for predicting continuous, numerical values, while classification sorts things into discrete, predefined buckets. So whenever you're trying to figure out what kind of machine learning you need, just ask yourself one question: am I trying to predict a quantity or a category?
Let's break those down. If a business needs to forecast a continuous sliding scale, they absolutely must use regression. Going back to our real estate example, the price of a home could be $400,000 or it could be $400,001, right? It's a continuous number. Other great examples of regression would be predicting tomorrow's exact temperature or forecasting the specific sales revenue for the next quarter.
Classification, on the other hand, is all about categories. Returning to our spam filter question from the beginning, categorizing an email into distinct spam or not spam buckets is a classic classification task. There is no sliding scale here. An email is either pure junk or it belongs in your inbox. Boom, done. Other examples would be a medical model deciding if a scan shows a benign or malignant cell, or a bank flagging a transaction as fraudulent or legitimate.
Okay, Section 4. How different algorithms think. Let's peek under the hood at the actual computational brains making these decisions. Two of the big ones you'll hear about are decision trees and neural networks. Now, decision trees act kind of like a giant flowchart. They split data based on really clear, rule-based logic. It is super easy for us humans to understand because it just asks a series of yes or no questions. Is the house bigger than 2,000 square feet? If yes, go left. Is it in the suburbs? If yes, go right. Neural networks, though, they are way more complex. They process data through multiple layers of interconnected nodes, constantly tweaking weights and mathematical equations at every single step. It makes them ridiculously powerful, but definitely a bit harder to interpret.
And you know what is truly fascinating? We've essentially modeled one of our most advanced algorithms, the neural network, directly after our own biology. The quote here really hits the nail on the head. Just like neurons in our brains fire off signals to process information, the artificial nodes in a neural network pass data forward to reach a final prediction. That is exactly how they handle super complex tasks like image recognition.
Which brings us to our final stop, Section 5, making better business decisions.
So why does all this matter? Well, from instantly stopping fraudulent credit card swipes to predicting which customers might default on a loan, businesses use supervised learning to make incredibly smart, data-driven decisions at a massive scale. Think about your favorite streaming app. When it recommends a movie, it is using supervised learning. It analyzes your past viewing habits, that's the input, to predict if you're going to click play on a new title, the target output. Or think about customer sentiment analysis, where an algorithm reads thousands of social media posts to instantly classify whether the public's reaction to a new product is positive, negative, or neutral. It is literally everywhere.
So I'll leave you with this thought. Which supervised learning models are working behind the scenes in your digital life right now? As you wrap up this explainer and go about your day-to-day, I challenge you to look a little closer. Try to spot those hidden algorithms constantly predicting your next move. Whether it's your GPS using regression to guess your arrival time, or your phone using classification to sort photos of your cat, supervised learning is the invisible engine powering our modern world. Thanks so much for learning with me today, and keep your eyes open.